Good afternoon, grade 10. Okay, this afternoon, we will have the continuation of the discussion yesterday. So let's have a review first. Do you remember the EM waves? Okay, so this time, I will tell you all the application and uses of the EM wave. So first, let's have the radiation. Radiation, when it hits something, can be absorbed, reflected, scattered, diffract, refract, and it transmitted. Okay, so which one is emitting the most radiation? Is it letter A, B, C, or D? The answer is letter B. Temperature of an object relates to the amount of radiation released. So the hotter, the more radiation released. So let's have this radio wave. So when you see this one, the EM waves, uh, the radio waves, it is in the last part. Okay, so meaning radio waves has a longer wavelength, so means it has a low frequency, because as what I've said yesterday, frequency and wavelength are inversely proportional. The longer the wavelength, the lower the frequency. Okay, what does AM and FM stands for? FM means frequency modulation, and AM, that is your amplitude modulation. So which is AM and which is FM in this wave? Is it letter A or letter B? Correct. It's letter A. That is your AM. And for B, that is your FM. Very good. Grade 10. So which radio wave has the higher frequency? It's the FM. EM waves have a number of important uses for communication. Various waves in the EM spectrum has different behaviors and therefore uses as they interact with matter. So as you can see, this one, the cell phone, and this one, that is, they use radio waves. And then for the satellite, they use microwaves. And this one is your remote control, that is your infrared. Okay, so what is radio direction and ranging? Okay, in short, it is a radar. How radar works? So radio waves bounce off of an object and return. Size and distance is then obtained. So as you can see there, look what happened to the waves. Okay, so unless the radio wave is deflected in a way that won't make it back to the radar device. So this would be bad because the radar would detect the bomber. So this is what actually happens. The bomber is undetected. So what are the advantages of using a digital message such as email or cell phone over handwritten mail? What do you think so? Okay, message travels at the speed of light. We have the 299 million, or we have the 300 million meter per second. That is the speed of light. And stored and organized on a computer and easily shared or copied and transmitted. That is the advantage. How about the disadvantage? Okay, what do you think the disadvantage for this? It can be easily erased, yes. And the next, we have the microwaves. It is the waves with wavelengths ranging from 1 meter down to 1 millimeter. Okay, like your oven. Your oven use microwaves. Can anyone correctly spell IR from the EM spectrum? Okay, it's the IM, that is your, or IR, that is your infrared. Okay, the infrared radiation or the infrared wave. So wavelengths between microwaves and visible light. So that is your infrared here. So when we compare infrared and microwave, which has the higher frequency, the infrared or the microwave? Okay, very good. The infrared. The infrared wave has a higher frequency than the microwave. Always remember, from here, from gamma rays to radio waves, the wavelength is increasing. The longer the wavelength, the lesser the frequency it has. Okay, remember that one. So infrared radiation is from about the pinhead to the cellular level, and it can be felt as heat. So as you can see there, it is from the NASA. Okay, that's an example for infrared, and can be used in meteorology, like if they can detect for a typhoon or the speed of the wind, and also it can be used for military and law enforcement purposes. Many animals, such as snakes, can see in infrared. Wow, that's amazing. But we cannot see infrared, unless if we will use some devices. Heat loss through the ears to cool down. Okay, so this one. Where is this house losing heat and needs insulation? What do you think? Oh, from this one, the ears is, or the heat here in the ears is lost and it starts to cool down. Look at the color. So in this part, where is this house losing heat and needs insulation? Okay, very good. That part of the house. And also infrared also used as a heat source. Okay, let's have the visible and the infrared difference between the images. So as you can see here in the picture of visible and the infrared. So in the visible, you can see the true colors. In the infrared, look at the difference of the images. Okay, so where can you see the visible light? It is between of UV and the infrared. Now, when we compare visible and UV rays, which has a longer wavelength, UV or the visible? Okay, very good. The visible. Visible has a longer wavelength than the UV. So meaning visible has low frequency than the UV. Okay, very good. Does anyone know this man? His name is Roy G. Biv, okay? So he is the one who discovered the rainbow. Remember the rainbow, the Roy G. Biv? That's the visible light. R stands for red, orange, yellow, green, blue, violet. Or we will put here for to become Roy G. Biv. So B, then indigo, then violet. Okay. White light consists of the following colors. So white light, that is the combination of all the light colors. So Sir Isaac Newton's experiment with prisms showing the visible spectrum. So you can also use clear bottle, and then you put it water there, and then you put it under the sun, and then you will use a white bond paper for the shadow to reflect it. And then later on, you can see a small portion of a rainbow. You can try that one at home. But if you want to have an easier way, if you have prism, you can use prism so that you can easily see the rainbow or the visible light. Okay, so when we study about the visible light, the Roy G. Bill, so red, it is here. So red, then infrared, violet, then violet. Ultraviolet, then violet rather. So now, my question is, what color has more frequency? Is it the violet or the red? Okay, very good, the violet. Violet has a higher frequency because it is near in the UV wave. Okay, and the red has a lower frequency. It is nearer to the infrared wave. So, are you colorblind? If you can see the numbers, then you are. Okay, what number is this? This is number, okay, number 12. How about this one? Okay, correct. It's number 35. You're not a colorblind. Okay, what it looks like if you are a colorblind? It's like this. So we see the flower in the left. A bee sees the flower on the right. Because most of the insects can see UV light than us. Okay, so when we look at the sunflower, the color is yellow. It's yellow. But when the bee sees a sunflower, they cannot see yellow. They can see violet colors. Okay, so some stains can be seen with UV light, like those seen on crime shows. So UV has shorter wavelengths than visible light. So meaning shorter wavelengths, so it has a higher frequency and it is more powerful than visible light. Okay. So when you want to expose your body in the sun, so this is what happened. You want to have that kind of body, the color is red already. So it turns into, or it leads you to have a skin cancer. That's why there are many creams or lotion that you need to apply in your body before you go to the beach, especially if it is summer. Okay, so here it is what we call ionizing. So avoid UV exposure as it can lead to painful burns and deadly skin cancers. You want that one? Okay. Yeah, he needs to have a sunblock. Okay. So let's have the X-rays. So they have smaller wavelengths and therefore higher energy than UV waves. So it is stronger than the UV. So it is used for medical examination, and you're familiar with this one? Like when you go to a doctor and then you want to have an X-ray. So this will be the result. Okay? X-rays can cause cancer if overexposed. That's why if you are pregnant, so it is not allowed or it is not advisable for you to undergo X-ray because it is risky for your baby. And of course, hands of early X-ray technician, as you can see, look at the hands. You want that one? Okay, and also X-rays used to study space phenomenon. X-rays don't make it through the atmosphere, so satellites are used from space. So the sun, that is the infrared image. And that is the X-ray image. Look at the difference. And then when you use gamma ray, that's the color. So let's have the gamma ray. So gamma ray, that is the highest form of wave. That is because it has the highest energy and it has the shortest wavelength. Emitted during radioactive decay of a fission product. And that is a very small number. So the smaller number you have in the wave, the stronger you are. So when you do scientific notation, this will be the result. That's incredibly small. So radioactive atoms and from nuclear explosions, that is your gamma rays. And then gamma rays can cause cancer and can also be used to treat cancer patients by killing cancer cells. So also, most of these waves is very useful if you will use it in a proper way. Do not expose yourselves every day in some dangerous waves. So if it is needed for you to have like x-rays, or if you have disease like cancer, so you need to undergo this treatment for you to have a longer life. Okay. So the name for the particles of a light is what we call photon. Okay, it is a bundle of electromagnetic energy. And photons are always in motion. Okay, so light has a constant speed to all of observers, which is faster, the sound wave or the light wave? Okay, that is the light wave. Light wave, it has 300 million meter per second. Then the sound wave, it has a 300,000 meter per second. So meaning the light wave is faster than the sound wave. So this time, this is your activity. So let's fill in the missing terms of the EM spectrum. So which part is it? What part is this? That is your, look at the number. Smaller, so it's the smallest number. Okay, very good. That is the gamma rays. Next, the X-rays, the UV rays, visible, the infrared, microwave, and the last one we have the radio wave. Very good. Okay, next again. Okay. Okay, very good. So you make sure you memorize the spectrum. Okay, now I want you to get your notebook and write your answer from this video. So for number 1, what wave is in here? You can pause this video for you to answer. Next, for number 2, what wave is this? Okay, number 3, what wave is being used here? Number 4, number 5, number 6, what wave is in here? Okay, number 7, number 8, number 9, and number 10. So again, you need to write your answers in your notebook and send your answers in Cerebro by clicking pre-recorded video answers EM Waves. Understand, grade 10? Okay, thank you so much, and that's all for this afternoon. Goodbye.